In this video, I will go through the Chapter 1, Section 1.1 of FS1 from Edexcel. Okay, the first topic is the expected value of discrete random variable. Okay, so the formula is E of x is equal to sum of x times probability of random variable x equals to x. Okay, so let's go through the example 1. A fair six-sided dice is rolled. The number of the uppermost face is modeled by the random variable x. Write down the probability distribution of x. Probability distribution of x. The best way is to draw a table just to make it a lot easier. Okay, so x and probability of random variable x equals x. So what are the possible values for lowercase x? So the six-sided dice should be labeled 1, 2, 3, 4, 5, and 6. Probability of random variable x equals to x. In this case, it means probability of random variable x equals to 1. What is the probability of the dice is landing on 1? Okay, it should be 1 out of 6 as it is fair dice. Similarly, the same thing for 2, 3, 4, 5, and 6. Okay, so the expected value E of x, so which is a part B of the question. It says use the probability distribution of x to calculate E of x. E of x is equals to sum of x times probability of x equals to x, which is, so this lowercase x represent the outcomes, okay, and probability of x equals to random variable x equals to x represent the probability of each outcome. So it would be 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. Okay, so if we add them up, we get 21 over 6, which is 3.5. So let's go through the explanation of this. If you know the probability distribution of x, then you can calculate the expected value. Notice that in example 1, which we just went through, the expected value is 3.5. But probability of x equals to 3.5 is 0, because none of the sides of the dice is labeled as 3.5. So the expected value of a random variable does not have to be a value that the random variable can actually take. Instead, this tells us that in the long run, we would expect the average of all rolls to get close to 3.5. So it is important. Instead, this tells us that in the long run, we would expect the average of all rows to get close to 3.5. Okay, so let's go through the example 2. Okay, so I just leave the example here just to example 2. The random variable x has probability distribution as shown in the table here. Probability of the outcomes would be 1, 2, 3, 4, and 5. Probability of x equals to 1 is 0.1. X equals to 2 is p, 3 is 0.3, 4 is q, and 5 is 0.2. Given that e of x is equal to 3, write down the equation involving p and q. So we know that e of x is equal to sum of x times probability of random variable x equals to x. Okay, so, and also we know that e of x is equal to 3 in this case. So let's write down the formula. Okay, so x times 1 times 0.1 plus 2 times by p plus 3 times by 0.3 plus 4 times by q plus 5 times by 0.2 is equal to 3. Okay, so 1 times 0.1 is 0.1 plus 2 plus 0.9 plus 4q plus 5 times by that plus 5 times by 0.2, which is 1 equal to 3. 0.1, 0.9, which is 1, and with this one, which is 2. 2p plus 4q, add 2 is equal to 3, take away 2 from both sides, which we get 1. Okay, so 2p plus 4q is equals to 1. Find the value of p and the value of q. Okay, so far we've got one equation for p and q. Okay, so let's just delete the question here. We've got the value for p and we've got an equation for p and q. So we need another equation to be able to work out the value of p and q, because we've got two variables here with only one equation. But another equation could be sum of 0.1 plus p plus 0.3 plus q plus 0.2 must be equals to 1, because the sum of probabilities must be equal to 1. So 0.1 plus p plus 0.3 plus q plus 0.2 is equal to 1, which means the outcome should be definitely one of these five outcomes basically. Okay, which adds up to 100% of 1. 0.1, 0.3, which is 0.4, 0.6. So therefore, p plus q is equal to 0.4. Okay, and we have 2p plus 4q is equals to 1. Okay, solving this simultaneous equation, which I leave it as a homework for yourself, just to do that. Okay, you should get p equals to 0.3 and q equals to 0.1. Okay, so let's move on to the next example. Example 3. Okay. Here is a question for example 3. Okay, let's leave the example here. Okay. It says a discrete random variable x has the following probability distribution. X, the possible outcomes are 1, 2, 3, and 4. Probability of random variable x equals to 1 is 12 over 25, 2 is 6 over 25, 3 is 4 over 25, and 4 is 3 over 25. Write down the probability distribution for x squared. Okay. So, to write down the probability distribution for x squared, let's draw the table again. Okay, and add one more column or row rather for x squared. So x squared and probability of random variable x squared equals to x squared. Okay, so what are the possible values for x? 1, 2, 3, and 5. 1, 2, 3, and 4. What will be x squared? 1 squared is 1, 2 squared is 4, 3 squared is 9, and 16. So probability of x squared is equal to 1 is 12 over 25. Because from the question it says the probability of random variable x equals 1 is 12 over 25. So, okay. Probability of x squared is equals to 4 is 6 over 25. Okay. And 9 is 4 over 25. 16 is 3 over 25. In other words, probability of x squared equals to x squared is the same as probability of random variable x equals to x. So it doesn't change at all. E of x squared, which is part B. It says to write down find E of x squared, which must be sum of x squared times by probability of random variable x squared equals to x squared. What is x squared? 1 times by 12 over 25 plus 4 times by 6 over 25 plus 9 times by 4 over 25 plus 16 times by 3 over 25, which adds up to 120 over 25, which is 4.8. Okay, so after watching this video, you should be able to do exercise 1A, which is page 4 and 5. Page 4 to